Imagine I have a beautiful tree that's filled with oranges. And I ask myself, what is the orange made of? How do I answer that question? Well, I want to look deeply inside the orange, so I magnify it. And I magnify it again, and if I keep on doing it, deep inside, sooner or later, I begin to see molecules come into view. But molecules are not the end of the story, because the molecules, I can enlarge them. And if I make them big enough deep inside, I begin to see atoms. Atoms are not the end of the story too, because we have electrons zooming around the nucleus. Deep inside, mostly empty space in the atom, but deep inside, we see the nucleus. So if I grab that and magnify it, I see that the nucleus is itself made of particles, neutrons and protons. And if I grab one of the neutrons and magnify it, I find yet further particles, little tiny quarks inside. Now that is where the conventional ideas stop. String theory comes along and suggests that inside these particles there is something else. So if I take a little quark and I magnify it, conventional idea says there's nothing inside, but string theory says I'll find a little tiny filament, a little filament of energy, a little string-like filament. And just like the string on a violin, I pluck it and it vibrates, creates a little musical note that I can hear. The little strings in string theory, when they vibrate, they don't produce musical notes, they produce the particles themselves. So a quark is nothing but a string vibrating in one pattern. An electron is nothing but a string vibrating in a different pattern. A neutrino, nothing but a string vibrating in a different pattern still. So if I take all of this back together, I have my ordinary orange, and if these ideas are right, they are speculative, but if they are right, deep inside the orange or any other piece of matter is nothing but a dancing, vibrating cosmic symphony of strings. That's the basic idea of string theory.
It's been a while since I have heard about string theory. For a while, that's all I heard about. Not so much anymore.
It's rather out of fashion, frankly, though this article wouldn't give you a clue to that. The theory faces so many obstacles and has no evidence in its favor that I think most scientists are probably pretty skeptical about its promise, though in this article they do quote a number of string theorists who are working in this area that are optimistic that something will come of it.
I'm sure there's some people who don't know what string theory is. Using their own definition, perhaps you can give us a definition or an overview of what we mean by string theory.
Well, she gives a nice definition in the blog here. String theory is an attempt to describe the whole universe under a single theory of everything. This would unify gravitation with the other fundamental forces of nature by adding extra dimensions of space-time and thinking of particles as minuscule vibrating loops.
Little strings.
Yes, it's an alternative to the standard model of particle physics, which thinks of the universe as made up of little fundamental particles. Here you have little loops of vibrating energy that are the fundamental building blocks of the universe. In other words, the theory doesn't predict a universe that has specific values for its fundamental constants. Rather, it allows this vast range of values to exist. In fact, around, as it says, 10 to the 500th different universes that would be consistent with string theory. Now, why is this even relevant? Why are we even talking about this? Well, this is important with respect to the argument for the existence of a cosmic designer from the fine-tuning of the fundamental constants and quantities of the universe. What we discover is that the fundamental constants of nature, like the proton-neutron mass ratio or gravitational force or the atomic weak force, are finely tuned to specific values, such that if you were to alter these values by a hair's breadth, the life-permitting balance would be destroyed and the universe would be life-prohibiting. And so the question is, how do you best explain this incredible, incomprehensible, really, fine-tuning of the universe for embodied conscious life? And one of the explanations would be, well, the values of these constants and quantities are physically necessary. Given the laws of nature, they had to have the values they do, and therefore the fine-tuning is not an occasion for surprise. The universe had to be that way, and it couldn't have been different. Well, that explanation of the fine-tuning is subverted by string theory, you see. If string theory is correct, it is not true that the values of the fundamental constants are physically necessary. Rather, string theory could be true, and there is this incomprehensible range of universes, 10 to the 500th power, all consistent with the laws of nature that would be predicted by string theory. And so it really would compromise fatally the explanation of physical necessity for the fine-tuning of the universe. Now, what's important to understand, Kevin, is that this so-called cosmic landscape doesn't really exist. This is not a multiverse of universes. This is just a range of possibilities. It's a list, as it were, a list of all of the different constants that would be consistent with the laws of nature. So Claire Moskowitz says at one point in her article, the so-called landscape of string theory is the incomprehensible number of potential universes that result from the many different solutions to string theory's equations. And the word we want to highlight there is potential. This is a list of the potential universes that could exist consistent with the laws of nature laid down by string theory. So this is important because there's some confusion later in the article where it suggests that string theory posits some sort of a multiverse of actually existing universes, where in fact these are just potential solutions to string theory.